Three-phase induction motor. In three-phase induction motor, first we must know electric torque production. When a magnetic field B passes in this direction and a coil having the current I in this direction, then this coil feel a force upward, and when a field passes in same direction and the current passes in opposite direction, then coil feel a force in downward. According Faraday's law, we know that when a current carrying coil is placed in a magnetic field, then coil feel a force. The value of force F equals to BIL Newton. Actually, this B is a vector quantity and I is also vector quantity, and L is the length. According right hand rule, which direction current is passes through, then which direction L, and then rotate the right hand palm into L cross B. The direction of thumb is the direction of force. If we have any cylindrical coil or cylindrical rotor, and this point and this point, if a current is entered at this point and this point the current is leaving, then this position the force act on upward and the force act on downward. This is F. Here leave the current, here enter the current. Actually, there are two types of torque. Electrical torque are two types. Number one, reluctance torque. And electromagnetic torque. Electromagnetic torque. Now, first, reluctance torque. If we have two pole N or S and any salient pole are placed at this location, and we know that the passes of flux from N to S. When we place the salient pole rotor, the direction of flux will change. Because the reluctance of rotor is less, so flux will be passes through it, and the reluctance of air gap is high, so flux won't flow in air gap. The property of flux choose the shortest path. Flux choose the shortest path, so straight the on path, we rotate the rotor in this direction. Then the figure become, this is N, this is S, and the rotor is like that. And then flux will passes in the center of the rotor. A force is developed on the rotor without any electric source or supply. A torque is produced on the rotor. This torque is known as reluctance torque. Now, second, one more point. If my rotor, this is N and this is S, if my rotor is obviously placed in this direction and flux will passes through it, then reluctance torque won't produce. Now, electromagnetic torque. Electromagnetic torque. Electromagnetic torque is produced or induced when the rotor takes the supply. That means this is N and this is S. And in electromagnetic torque, if we use the cylindrical rotor, then the flux will passes through this direction. The path of flux is straight, so the rotor won't rotate the absence of power supply. When we give the power supply, then rotor rotate. In cylindrical type rotor, no need for reluctance torque because each and every position the air gap is equal. From this position to this position, this position to this position, this position to this position, the air gap is equal. So in cylindrical rotor, reluctance torque won't produce. In cylindrical rotor, only electromagnetic torque produced. In this diagram, reluctance torque won't produce, but electromagnetic torque produced. In this case, reluctance torque reluctance torque produced, and also electromagnetic torque produced. In this case, the reluctance of air gap is so high, so maximum flux want to passes through rotor, so rotor should be rotate, therefore the path of flux must be straight. We know that all the rotating machine have some flux. Now, type of flux. Type of flux. There are two types. Number one, single phase flux. Number two, three phase flux. The single phase flux, also known as pulsating flux, and standing wave. Standing wave. And three phase flux is rotating flux. Is rotating flux or traveling wave. अब three phase flux is also rotating, so we should know why three phase flux is rotating. Now the first, traveling wave. If we have any function with respect to position and time, that means b of xt equals to Vm sin omega t plus beta x, where x is position and this t is time. At time t equals to 0, at t equals to 0, then v of xt equals to Vm sin of beta x. That means if t equals to 0, then v of xt equals to Vm sin beta x. If you draw the curve of v of xt, it's like that. Vm sin beta x, that means this curve is like that. And this is Vm, and this curve is Vm sin beta x. When at the second instant at t equals to t1, then v of xt equals to Vm sin of omega t1 plus beta x, sin omega t1 plus beta x. Now draw the curve Vm sin omega t plus beta x, that means this beta x in the angle of added, then the curve is leading. That means the second curve, that means at the time t equals to t1, the curve lead the first curve. That means this is at t equals to 0, and second curve is leading. This curve is leading. This curve is t equals to t1 at t equals to t1. Now if we take the third instant at t equals to t2, at t equals to t2, then v of xt equals to vm sine of omega t2 plus beta x. That means this omega t2 or this omega t1, that means t2 is greater than t1, so omega t2 is greater than omega t1. That means the third curve is also leading the previous curve. That means the third curve is like that. In all the curve, if we see with respect to position x, the curve, if time is increasing, the curve is shifting on left side, and when the curve shift on left side, that means the curve is leading at t equals to t2. That means we see the maximum value of the all curve are shifted. The first, the maximum point is here, and the second, the maximum point is here, and the third, the maximum point is here. The curve, the maximum point is shifted. The maximum point is shifted on backward side. That means this type of wave is called backward traveling wave. Now if we take one more equation, v of xt equals to vm cos omega t minus beta x. If at the instant of at t equals to 0, then v of xt equals to vm cos of minus beta x, and it may be written as vm cos of beta x. Now if you draw the curve like that, bm cos beta x at t equals to 0. bm cos beta x, we know that the curve of cos x is at the origin point is maximum. It's the curve that at t equals to 0. Now the second instant at t equals to t1, then v of xt equals to vm cos of omega t minus beta x. It may be written as vm cos of beta x minus omega t. So we take the some value is minus of the angle beta x. The value of omega t is subtracted from beta x. So we can say that the next curve is lag the previous curve. So we draw the curve Vm cos beta x minus omega t1. So the curve is like that. Like that. This instant is at t equals to t1. Now we take the third instant here, omega t1. Third instant at t equals to t2. So v of xt equals to vm cos omega t2 minus beta x. It may be written as vm cos beta x minus omega t2. The same if t2 is greater than t1, so omega t2 is greater than omega t1, then the third curve is lag the previous of the both curve. Now the third curve is here. If you plot this instant is at t equals to t2. If we see the maximum point, again shifting, first the maximum point is here, the second is maximum point is here, a third the maximum point is here. If we see the curve is shifted on right side, when the curve is shifted on right side, then we called this type of curve, we say that forward traveling wave. Forward traveling wave. Now to find the traveling speed, of wave, so if we see any curve, like this, and if we traveling with wave, then we get every peak is maxima, else constant. If suppose if we travel with the curve, then each and every point is maxima or else constant. Each and every point, here or here, here or here, then we can say that omega t omega t minus beta x equals to k. Differentiate it with respect to time, then omega minus beta dx upon dt equals to 0. That means dx upon dt equals to omega upon beta. This is known as phase velocity. Phase velocity. Now standing wave. Standing wave or pulsating wave. That means single phase. If you take any equation v of xt Vm sine of omega t into cos of beta x at the instant of at t equals to 0, v of xt equals to cos of beta x. Now we draw the curve like that. Cos t equals to 0, then sine omega t equals to 0, only cos beta x remaining, so the curve is like that at the instant of at t equals to 0. Now second instant at t equals to t1, then v of xt equals to vm sine of omega t1 cos of beta x, and again x is varying, so cos beta x varying, then vm sine of omega t, that means the magnitude of in this curve is higher than the previous curve. Previous equation have magnitude the 1, in this case vm sine omega t1. So the curve is at t equals to t1 like that. This instant is at t equals to t1, and again at t equals to t2, so the curve v of xt equals to vm sine of omega t2 cos of beta x. Again magnitude is higher, so the next curve become here. And so if we travel in negative side, so same the curve is like that. Okay. In this type of wave, the magnitude is increasing or decreasing, but the nature of this curve is same. That means the nature of curve is same. That means this type of curve is known as standing wave. One more point, if we have one forward traveling wave and one backward traveling wave, then we get the standing wave if v of xt equals to vm sine of omega t plus beta x plus vm sine of omega t minus beta x. Then if we solve, then we get 2 vm sine omega t into cos of beta x, and we know that this curve is standing wave. This equation represents the standing wave. Now we know that in three phase the voltages are b of a dax equals to vm sine of omega t, and v of b dax equals to vm sine of omega t minus 120 degree, and v of cc dax equals to vm sine omega t plus 120 degree, or vm sine of omega t minus 240 degree. That means this curve is represent the forward traveling wave. So the curve is traveling. So in three phase the flux is rotating. Thank you.